topic that will be covered in this topic is basic concept of matter, the development of the atomic model, atomic structure, and isotopes and its uses.
Oops, wait a second.
Alright students, before we start our lesson, let's jot down the pre-lesson question. Okay, the number 1. Who is the scientist that proved the existence of neutron in the nucleus? Question number 2. How many valence electrons are there in carbon elements? And the last question. What is the use of isotope cobalt-60? 2.1 Basic concept of matter.
Alright, for the learning standard, by the end of this lesson, students should be able to describe the matter briefly, explain the change in the state of matter, determine the melting point and freezing point of naphthalene through activity. Matter is something that has mass and occupies space. Matter consists of particles that are tiny and discrete. Matter exists in 3 states, which is solid, liquid, and gas. Here an example for you. You eating an ice cream while watching TV, and by a few times, the ice cream start to melt. Did you know why? This is because the ice cream absorbs heat energy from the surrounding and changes the state of matter of the ice cream from solid to liquid. This is caused by 2 processes, which is heating and cooling.
These figures shows the conversion among state of matter through the process of heat absorbed or heat release. When heat energy is absorbed or released, changes occurs in kinetic energy, arrangement of particles, and attraction force between particles, causing the state of matter to change. As you can see, there's changes from solid to liquid, liquid to gas, gas to solid, and also solid to gas, gas to liquid, and liquid to solid.
Solid. Particles are closely packed in an orderly manner. Kinetic energy is very low, and attraction force between the particles is strong. For the liquid, particles are closely packed but not in an orderly manner. Kinetic energy of particles is higher than solid state, and attraction force between the particle is strong but less than solid state. For gas, particles are far apart. Kinetic energy of particles is very high, and attraction force between particles is so weak. Students, the matter can be classified into 2, which is the elements and the compound. What is the difference between elements and compound? Okay, the elements is, for example, atom and molecule. And for compound, example is molecule and also ion.
The subtopic 2.2, the development of the atomic model.
For this subtopic, at the end of the lesson, students should be able to state the subatomic particles in the various elements, compare and contrast the relative mass and the relative charge of proton, neutron, and electron, sequence the structure of atomic model based on atomic models of Dalton, Thomson, Rutherford, Bohr, and
The figures shows the subatomic particles found in an atom, which is made up of proton, neutron, and electrons. So, do you see any similarities or difference in these three types of subatomic particles?
Alright, for the relative mass, or the symbol is AR, it is a dimensionless physical quantity defined as the ratio of the average mass of atoms of a chemical element in a given symbol to the atomic mass of constant. The atomic mass constant is defined as being 1/12 of the mass of a carbon-12 atom. Since both quantities in the ratio are masses, the resulting value is dimensionless. Hence, the value is said to be relative. Students, have you ever thought how the atomic structure model is produced? The atomic structure model that we know today is the product of many scientists' effort. Studies on atoms started since the introduction of atomic theory by Democritus, a Greek philosopher, around 500 BC. Here shows the historical development of the atomic structure model. The first model was produced by John Dalton and is called Dalton Atomic Model. According to Dalton, matter is made up of particles called atoms, and atoms is the smallest particle with a spherical body that cannot be created, destroyed, or divided further. Same elements have the same atoms. Next, after that, there's Thomson atomic models, created by J.J. Thomson. J.J. Thomson discovered negatively charged particle called electrons. Atom is positively charged sphere with several electrons in it. There is electron and also positively charged sphere. Next, the next model is Rutherford model. Created by Ernest Rutherford, nucleus is the center of the atom and discovered positively charged particle called proton in the nucleus. Almost the whole of atomic mass is concentrated in the nucleus, and electrons move outside the nucleus. Right. The next model is Bohr's atomic model. The scientist that discovers this model is Niels Bohr. According to Bohr, electron is an atom moved in shells around the nucleus. And the latest model that we use nowadays is Chadwick atomic model. The scientist that behind this model is James Chadwick. Chadwick discovered neutral particles that are neutrons in the nucleus. Neutrons contribute almost half of the mass of an atom.
2.3 Atomic structure.
At the end of the lesson, students should be able to define the proton number and nucleon number, determine the nucleon number, proton number, and number of electrons in an atom, write the standard representation of an atom, construct an atomic structure diagram, and electron management.
Let's look at the table. As you can see, what is the relationship between the number of proton and proton number, and the relationship between the nucleon number and the proton number. The table shows the proton number and nucleon number of oxygen atom, sodium atom, and chlorine atom. The number of protons in the nucleus of an atom is known as the proton number. The total number of protons and neutrons in the nucleus of an atom is known as the nuclear number. The nuclear number is number of protons plus number of neutrons, and nucleon number, proton number plus number of neutrons. Atoms of different elements have different proton numbers. For example, sodium atom has proton number of 11 and chlorine atom has a proton number of 17. Students, are there any two elements with the same proton number? Can you explain why? The table shows the comparison among the number of protons, neutrons, and electrons when a chlorine atom accepts an electron to form a chloride ion. What are the changes in the number of proton, neutron, and electron? You can see in the table. A chlorine atom accepts one electron to form a chloride ion. Thus, a chloride ion has one electron more than a chlorine atom. The number of protons and neutrons in a chlorine atom and chloride ion are the same. Therefore, during the formation of ion from an atom, the number of protons and neutrons in the nucleus remain the same.
An atom can be represented using a standard representation as shown in figure. The A representing the nucleus number, the Z representing the proton number, and the X is symbol of the elements. Atomic structure and electron arrangement. Electrons of an atom orbit around the nucleus in their respective shells. Electron will fill the shell closest to the nucleus first. When the shell closest to the nucleus is full, electron will fill the next shell. And the maximum number of electrons in the first 3 shells for elements with proton number 1 until 10 is shown in this figure. The first shell, which is the closest one to the nucleus, can occupy to 2 electrons. The second shell occupies 8 electrons, and the third shell occupies 8 electrons.
Alright, the last subtopic for this chapter is 2.4, Isotopes and its uses.
Alright, at the end of the lesson, students should be able to deduce the meaning of isotopes, calculate the relative atomic mass of isotopes, and justify the usage of various isotopes in various fields. Alright students, this figure shows 3 atoms of hydrogen element. All these 3 atoms of hydrogen have the same proton number but different number of nucleons. These hydrogen atoms are known as isotopes. Isotopes are atoms of the same element and with the same number of protons but different number of neutrons.
Isotopes are atoms of the same element with the same number of protons but different number of neutrons. For relative atomic mass of isotope, most elements exist naturally as a mixture of 2 or more isotopes. Relative atomic mass of this element depends on the natural abundance of isotopes in a sample. Natural abundance is the percentage of isotopes present in a natural sample of element. The relative atomic mass can be calculated from the natural abundance of an element containing isotope using the following formula. Students, isotopes are used widely in various fields, as you can see in the table. For example, in the field of medicine, the cobalt-60 is used in radiotherapy to kill cancer cells without surgery. Also, the cobalt-60 is being used to sterilizing surgical tools. Iodine-131 is used for the treatment of thyroid disorders such as hypothyroidism and thyroid cancer. In the field of agriculture, phosphorus-32 is used to study of plant metabolism. In the nuclear field, uranium-235 is used to generating electricity through nuclear power generator. In the field of archaeology, carbon-14 is used to estimate the artifact or fossil age. And the lead-210 is used in determining the age of sand and earth layers up to 80 years. In the industry, hydrogen-3 is used as a detector to study sewage and liquid waste. And lastly, in the field of engineering, sodium-24 is used to detect leakage in the underground pipes. Development in the field of science, specifically chemistry, has maximized the use of isotopes in various fields. Isotopes are used for sustainability of life. The use of isotopes causes both positive and negative effects on the environment and society.
Don't forget to study and stay safe and stay home. Bye. Assalamualaikum.